And now it's time for
a tiny bite
of knowledge.
Sarah, I've got a couple of questions for you, a couple serious questions for you.
That's good. I'm a serious person most of the time.
Have you ever thought about what actually makes up a soil?
Absolutely. I think about soil all the time because it's fun to think about soil.
That's what I kind of figured. I kind of figured you could be fun to think about soil. I'm glad I came here for this.
Absolutely. So let's just talk for a second about what is in a soil, right? So a soil, by and far and away, is 45% mineral component. That's the component that all of us as human beings think about all the time. 5% organic matter, 25% water, and 25% air. Now, these things can kind of change a little bit, right? I mean, it depends upon where you're at, what's going on, but for example, if you're in a drought condition, you're going to end up with a lot more air in your soil than water. If you're in a saturated situation, you probably don't have much air in your soil. If you're in a peat bog, for example, you probably have more than just 5% organic matter out there. So these things can change. But on a whole, when we're thinking about like what a quote unquote normal or ideal soil has, it's that 45% mineral, 5% organic matter, 25% air, and 25% water.
One way and one term you might hear that kind of covers this concept of like how much the whole soil itself, these four components of soil, the mineral component, the organic matter component, and then also the air and water. One term that you'll hear that measures this is the bulk density of the soil. And so what that includes is just how much that dry soil itself weighs per the volume of it. And it might sound like it's a really easy measurement, and it kind of is, right? Like once you submit a bulk density sample to a lab, it's very easy for them to dry that down and measure the weight of it. However, this is where things kind of get complicated, and it comes back into what we're trying to get at and what we're trying to measure with bulk density. Many of you have probably heard about bulk density in the context of trying to reduce your bulk density, trying to make your soil less dense, because often we think about compaction when we talk about bulk density. Because when you think about it, what happens is, say, if you're just like a garden soil or maybe a part of a field that's really wet, when you put a tire over that and you compress that soil when it's really wet, what happens is you kind of squish all of that air and that water out to the side, and you get a really dense soil, right? And without a lot of shrinking and swelling activity, that might stay dense for a long time.
And when you're talking about a dense soil, you mean there's not a lot of space in there for air or water to be, correct? In other words, all of the soil particles are compacted together, and now there's no longer room for that water and air.
Yeah. So like when you think about it, like you're not just 45% mineral, you're probably closer to like 70% mineral, same amount of organic matter, and then a lot less pore space. And so that's often what we think about when we think about this term of bulk density. And so getting into like why and how the measurement part of it is really important is that it doesn't take a normal soil probe to measure bulk density. It's going to take something that you can get a wide area of the soil to measure with. And then the best way is to take like a big old cylinder and then slowly tap the top of it with like a slide hammer so that you're not compressing the soil itself as you're putting that probe into the ground to collect that bulk density sample. Because again, like what we're trying to get at is as the soil sits in the ground, how dense is it? How much of the area of the soil is made up by the pore spaces of the soil? And if we're going to take a tiny soil probe and press it into the ground, we're going to compress a lot of that, and we're going to increase the bulk density of it if we're just using, like a regular 1-inch like wide hand probe to do that.
So I love this conversation because actually taking bulk density measurements and the reality of the sense is actually one of the most difficult measurements that you can actually perform as a soils person, because of what, quite frankly, a pain in the butt it is to actually pound that cylinder into the ground. But I'm going to back up for a second, and I'm just going to read the text textbook definition of bulk density is defined as the mass of a unit volume of dry soil. In other words, you have a known volume, that cylinder that Jody was just talking about pounding into the ground. So we know the volume of that cylinder, and we're going to pound that into the ground, pull that out, carefully get all the soil out of that cylinder. We're going to weigh it before we dry it for 24 hours at 105 degrees Celsius, pull it back out and weigh it again, take those differences and divide that by the volume so that we get that known bulk density. So that is going to help us understand the amount of solids, dry solids that are in that soil over the rest of the space of that soil, which could be taken up either by water or air. And again, just like Jody was talking about, roots don't grow through concrete and compacted areas very well. We want to have enough pore space and enough air and water so that those soils can really, so that the roots can really explore that soil. That's when we have really good crop growth happening.
Yeah, like it's so funny because like talking about bulk density, it's kind of like an esoteric concept, right? Like this bulk density, whoa, how fancy is bulk density? But what it comes down to is like, is there
pretty
space
fancy
in the soil?
If you ask me? It's really fancy, just like you and me, Jody.
Wee. Oh my God. But like what it comes down to is like, is there room in the soil for there to be air for the roots to absorb? Is there room in the soil for water to be stored? Those are really, really important things. And so there are a couple of things that can impact bulk density beyond like whether or not it's being squished. So like, here's some things to think about. Like when the typical bulk density numbers that you're going to see are probably going to be something around like 1.3. That's like the textbook medium textured soil with about 50% pore space that's filled with water and soil, or water and air, excuse me. So 1.33 is a quote unquote standard, but like there isn't really a standard. Like this is all going to come back to what the texture of your soil is. Typically sandy soils are going to be more dense because those sands compress and they don't let a whole lot of air in. And that sounds counterintuitive. You might think, oh, well, I've got a really light soil, a light sandy soil. That doesn't mean that it, what does it actually mean? Right? How heavy is a clay?
But how heavy is a clay? Well, I have been around some Fargo clays for my entire life, and the farmers routinely refer to them as heavy clays. How much do those clays actually weigh? It's a big joke in the soil science world, in my opinion. But Jody, you bring up a really good point when we start thinking about sands versus clays. One of the things that's really important in a soil is that organic matter component, because that helps the soil particles, the clay particles, stick together when we've got organic matter in there. And sands generally tend to have less organic matter in them. So if you've got a sand that's got not a lot of organic matter, yeah, it's going to compact on top of each other. And roots are going to have a more challenging time exploring that than a clay that is well aggregated with a lot of pore space in it. So those are some things that are interesting to think about. And when we think about soil crusting, so one of the issues that I've worked with farmers is when crops emerge in soil crusting. Okay, my background is I've scouted a few sugar beets in my day. And when we get crusting in sugar beets, there's little tiny cotyledons that need to get out of the ground. Well, it would always seem that when we would go to the sands, when we'd have those crusting issues, it would kind of seal up solid. And there was never really enough, if the sun would bake that sand, there was never really enough organic matter in there to allow that the aggregates to kind of stick together. The solids just kind of stayed there, layered together, and would seal up tight. Whereas in the clays, a lot of times those aggregates, when they start to dry out, the aggregates are getting stuck together because of the organic matter, and they kind of crack up. And then all of a sudden you'll see, a big, huge, thick piece of crust, but it's broken and the cotyledons, the plants can actually push their way through, where on the sands you can't do that. And it's probably time to go get the rotary hoe.
But thinking about this, right? So like, okay, the point is like, even though you might think of like clays as being heavy, counterintuitively, these clay soils, they've got higher amounts of organic matter, and they typically have more pore space than sands. Sands just can't stick together, or like they don't stick together very well. They kind of just fall and compress on top of each other, which leads to what Sarah mentioned, the soil crusting. But it also means that sands have typically a higher bulk density, even though, we refer to them as being a quote unquote lighter soil. And then clays, on the other hand, typically have lower bulk densities. So again, the point I want to make here is that there are some things that do affect bulk density beyond, trafficking or driving across something. There are these other factors that also affect that bulk density as well. Same thing, like if you think about a soil horizon, and let's all remember that soil isn't just what we see on the surface. There's soil also below it, all the way down to the parent material of that soil. And typically, as we go farther down that soil profile, we're going to have higher bulk densities as we go farther down. That comes down to again, like Sarah mentioned in her story, when there's organic matter, that helps create pores. And when we get farther down from the surface, there's less organic matter that's just there. And so there's just less pore space because of that. So that increases the bulk density. And then, of course, as you think about it, right, if an acre furrow slice, a 6-inch acre furrow slice of soil is 2 million pounds, that's a lot of weight that's compressed in these other layers too. And so as you go farther down in a soil profile, your bulk density is going to increase. And so the reason we think about this is because if we're starting to think about these really big, like, landscape measurements, if you're trying to figure out anything total wise of a soil, or like how much phosphorus is in a 6-acre furrow slice, one of those things that you have to consider, and I'm not talking just like soil testing and figuring out what your soil test phosphorus level is. I'm thinking about, like, if you were to ask the question, how much total phosphorus is there in 12 inches of soil, one of the base questions you're going to have to find the answer to is, what is the bulk density of that whole 12-inch profile? If the bulk density is 2.65, which is extremely dense, that is typically what we think of as being like the bulk density of a rock, you're going to have a way different answer than of the amount of phosphorus that's there versus if you were working with a 1.33 bulk density soil.
I also think it's important to think about some of the human interactions with bulk density and some of the things that can happen. So when we do tillage in soils, one of the things that happens, so initially when you do that tillage pass, you're going to introduce more air into that system. But one of the things that also happens is that soil structure, that aggregation, is destroyed. And so then when you end up having rain again, you kind of compact. Those aggregates are no longer there for the stability, and the soil particles stack up on top of each other. That generally tends to increase the bulk density of a soil. And so that is why we think about heavy tillage systems having maybe a little bit more issue with compaction than areas where no-till doesn't happen. Also, if you're transitioning into no-till, that's one of the reasons why you go through that yucky stage, like a couple of years in, where you probably have that bit of reduced growth. That's because you're no longer tilling your soil. And now we have to kind of work through that process of getting those aggregates developed again in the absence of that tillage. Because, again, you've destroyed the aggregation with your tillage, and now you need to let those aggregates form and let the organic matter, let those aggregates stick together again.
Yeah. So I think the big takeaway in all of this, even though the whole point of this was to discuss bulk density and define it, I think the biggest takeaway here is that the soil isn't just, what we see in terms of the black or brown stuff sitting on the surface. It's also about the pore space. It's about how much air and water is able to move through our soil. And that's a really important consideration. We can't neglect the other fractions of this living thing that is our soil.
We cannot forget about the importance of the air and the water and the organic matter that goes along with the mineral component. Wow, Jody, this is a really dense topic.
It really was. It was very, in the words of us in the East, a very heavy topic.
Very heavy soil, but an important one. And I certainly hope that the bulk densities out there in the soils are bulk densities that allow for great plant root exploration and plant growth.
Tune in next time for a tiny bite of knowledge from GK Technology, where we have a map and an app for that.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.